In our last maths class, we learned about how we can do the graph of a function. We also learned to distinguish between the graph of a function and the graph which is not the graph of a function. In today's class, we are going to learn about composition of a function and inverse of a function. Okay. So, what is composition of a function? So, there are times when we hook two machines together. Okay, we combine two machines. Like if we have a juicer and we put fruits in the juicer, we get a fruit juice, and we use that fruit juice to make something else in another machine. So here, what we are doing, we are taking the output of one function and putting and using it as the input of another function. So this is what the whole concept of this is the whole concept of composition of function. Okay, so how do we represent it? We represented it like this, like if we say f of g of x. Okay, so here x is the input. This is one function, and g of x is the output of that function, and that g of x, that is that output, we are putting again in another function, that is f. So we are using the output of one function as the input of another function. Okay, so this is the whole concept of composition function. So also it is represented as like this. Okay, this is same as this. Okay, this was same. So let's proceed with one question. If f of x equal to 3x plus 7, g of x equal to 2 root x minus 3, then f of g of 3 is equal to what? And g of f of 3 equal to what? Okay, so you may pause the video and think about the solution of this question. Okay, so the answer is first we have to find f of g of x. Then only we can find f of g of 3. So what is f of g of x? So first we have to think what is g of x. So what is the meaning of f of g of x? That we are putting x first in the machine g. Okay. So what is the output we are getting? We are getting 2, 2, 2 root x minus 3. This is the output we are getting after putting x in g. This output we are again putting in function f. Okay. So what we will do? This is the output. So this output we will put in f. So what we will do? We will put 3 into 2 root x minus 3. This is the output we are putting in f plus 7. Okay. So f is such a machine that it multiplies the input into 3 and adds 7 to it. Now our input is the output of g, which is 2 root x minus 3. So it will do the same thing with this this input, that is 2 root x minus 3. So it will multiply it by 3 and add 7 to it. So it is 3 into 2 root x minus 3 plus 7. Okay. So now we are getting 6 root x minus 3 plus 7. Okay. So this is f of g of 3. F of g of x. Okay. So now we have to find f of g of 3. So we will put 3 in the function. So it will be x equal to 3. If we put, then we will get this value as 7. Okay. So f of g of 3 is 7. So this is the answer of our first question. Then we will proceed to g of f of 3. So we know that f of x equal to 3x plus 7 and g of x equal to 2 root x minus 3. Now we have to find g of f of x. So what we are doing, we are putting x in function f, we are getting the output, and then the output we are putting in g. So what will happen if we put x in f? It will give 3x plus 7. Okay, so this is 3x plus 7. Now this 3x plus 7 we will put in g. Okay, so what will be the value? It will be g of 3x plus 7. That is equal to, g is such a function that will subtract 3 from the input, take its root over, and again multiply it by 2, the answer by 2. So it will be 3x plus 7 minus 3 square root into 2. Okay, so it will be 2 root 3x plus 4. Okay, so this is f of g of f of x. Okay, this is g of f of x. So we have to find this at 3. So it will be, we put 3 here, x equal to 3, then it will be 2 root 13. Okay, so as you can see that g of f of x and f of g of x, the value at 3, it is coming different. Okay, so last time we got 7 and this time we are getting 2 root 13. So it shows that f of g of x and g of f of x are not same functions. Okay, they are different. They may be same, they may be different. Okay, so you cannot say that g of f of x and f of g of x both are same thing. So those two may be different. Okay, so let's go to another question. So in this question only, so this is f of x, this is f of x, this is g of x. The question is, if f of g of a, g of a equal to 25, then find a. Then a is what? F of g of a, this is f of g of a equal to 25. Then a equal to what? So you may pause the video and think about the solution of this question. Okay, so we know that g of a, first when I see the question that it is to find out f of g of a, so first we have to find out what is g of a. So we already know that g of a equal to 2 root a minus 3. This is actually the continuation of the same question, so I'm doing in the same way. So g of a is 2a root a minus 3. Now we have to find f of g of a. Okay, so here we have to put g of a inside the function f. So it will be 3 into 2 root a minus 3 plus 7, which is equal to 6 root a minus 3 plus 7. Okay, so we know that f of g of a is equal to 25. So here 6 root a minus 3 plus 7 equal to 25. So 6 root a minus 3 equal to 18. Root a minus 3 equal to 3. So we will square both sides. A minus 3 equal to 9. So a equal to 12. Okay, so now we have got this answer. So another question is, with a continuation of same question, f of x equal to 3x plus 7, g of x equal to 2 root x minus 3. So you have to tell me if g of f of minus 7 is defined. Okay, so you have to tell me it is defined or not. So you may pause the video and think about the solution of this question. Okay, whenever I see g of f of minus 7, then first I find f of minus 7. So what is f of minus 7? So we will put minus 7 in f of x. So it is 3 into minus 7 plus 7 minus 21 plus 7 equal to minus 14. Okay. So now we are getting this whole thing as minus 14. Now we will put minus 14 in G and see if it is defined or not. If I put minus 14 in G, then it will be minus 14 minus 3 square root into 2, which is equal to 2 root minus 70. So as you can see that we cannot find the root of a negative number, okay, because it will give rise to complex number, and which is not defined. We are only defining function for real numbers, so this thing is not defined. So uh, we cannot put minus 7 inside minus 14 inside g, so this thing is not defined. This whole thing g of f of minus 7, this thing is not defined. Okay. So again the continuation of this question. So if h is a function which is equal to g of f of x, find domain of h. Domain of h. Okay. So you may pause the video and think what is the domain of h. Okay. So first we have to find g of f of x. So we had already found it out again. So f of x is 3x plus 7. F of x is 3x plus 7. So we will put g of 3x plus 7, which is equal to g of 2 into root 3x plus 7 minus 3. It is 2 root 3x plus 4. Okay. Now here we have to find the domain of this function. This whole function domain we have to find. So how can we find it? So we know that we cannot find the square root of a negative number. So 3x plus 7 must be greater than or equal to 0. It must be positive or 0. So 3x is greater than equal to minus 4. X is greater than equal to minus 4 by 3. So it can be written as minus 4 by 3 to infinity. This is square bracket and this is square. Okay. So the domain of this h is minus 4 by 3 to infinity. Okay. So another question we will do. It is a different question, different from the last. So here I am defining a function f of a equal to a minus 2, and capital F of a and b is defined as b square plus a. Okay. So now we have to find f of 3 comma f of 4. This is capital F, this is small. So you may pause the video. It is a very simple question. Try to solve this question. Okay. So first we have to find f of 4, small f of 4. So f of 4 equal to, we know it is 4 minus 2 equal to 2. So now we have the value of f of 4. So we will find capital f of 3 comma 2. Okay, because f of 4 is 2. So 3 comma 2 will be, it is b square plus a. So it is 2 square plus 3 equal to 4 plus 3 equal to 7. Okay, so this is the value is 7. Now we will move to inverse of a function. So now we'll move to inverse. So what is the inverse of a function? Suppose we have a function, say f of x. F of x is a function. And what we found that when I put 3 in this function, the output is 4. When I put 5 in this function, the output is 7. Okay. So this is a function like the inverse of this function is another function in which if I put the output of this function, then it will give the input. Means it will just reverse. Means if I put 4 into g of x, that is the inverse of this function, then it will give 3. If I put 7, then it will give 5. Okay, similarly for all the inputs, all means the input and output will be reversed, just reversed in this uh, function g of x. So that is called the inverse of g of x, inverse of f of x. Okay, so the notation, if g of x, that is the inverse of f of x, is written as f inverse like this. It is f minus 1. This is the notation. This is the notation. Okay, like this we write the inverse. So one working rule that you can use is that if g of x is the inverse of f of x, this is the inverse. Okay. So one property is that f of g of x equal to x for all values of x in the domain of g. Okay, so x should be in the domain of g because we are finding g of x. If x will not be in the domain of g, then we cannot find g of x, and if we cannot find g of x, then we cannot find f of g of x. So for every x should be in the domain of g. Similarly, g of f of x will also be equal to x. Okay, so in both this is the working rule for inverse. Okay, so g is the inverse of f. So f, and f is also the inverse of g actually. Okay, so now we have to find the inverse of a function. This is the question. If f of x equal to 3x minus 5, find its inverse. Okay, so you may pause the video and think what is the solution of this question. Okay, so one way to solve this question is that I have to find the inverse of this function 3x minus 5. So I will put it equal to y. Okay, so here then I will write x in terms of y. So 3x equal to y plus 5 and x equal to y plus 5 by 3. Okay, so this function, this y plus 5 by 3, don't be confused by the variables because variable can be anything. So this y plus 5 by 3, when I put any input in this function like 2, 3, you can see that if I put 2 in this function, the value is 1. 2 f of 2 equal to 1. And this function y plus 5 by 3, if I put 1, if I put, this is, let's say, g of x, g of 1 equal to 2. So similarly, you can check this for all the outputs and inputs of f. You can see that it is just reversed. All the outputs of f is the input of this new function y plus 5 by 3, and it gives the same output as the input of f. Okay. So here you can see that y plus 5 by 3 is the inverse of this function f of x. So we can write it in terms of x. Don't be confused that it is y or something like that, because y is also a variable. Like it is a function that puts any for any input, it does adds 5 to it and divides it by 3. Okay. So this new function g of x, that is inverse of x, f of x, is x plus 5 by 3. Okay. So this is x plus 5 by 3. This is the new inverse. So now we have another question. So this is a little tricky question. If g of x equal to 2x square minus 9, then tell if it if it has an inverse or not. So you have to tell me if this function has an inverse or not. So you may pause the video and think about the solution. Okay. So here you can see that if I put 1 inside this function, I will get 2 minus 9, that is equal to minus 7. Also, if I put minus 1 in this function, then I will get 2 into minus 1 square, that is 1 minus 9 equal to 2 minus 9 equal to minus 7. So you can see that at 1 and minus 1, it is giving the same output, that is minus 7. So if it has an inverse, think that it has an inverse. Let us assume it. So when I put 7 inside that new function, then it must give the input, that is, if we give now two outputs, that is 1 and minus 7. Okay. So in our new inverse function, f of that g of x, say f of x, so f of minus 7 will be 1 as well as minus 1. Now you think that it violates the basic definition of function. The definition of function is that for every input we will get only one output. But in this new function that we call the inverse of g, for input minus 7 we are getting two outputs, that is 1 and minus 1, which is not possible. So that new function is not a function at all. Okay. So from this we can conclude that g of x doesn't have an inverse. Okay, it has no inverse. So whenever any function for it is for two inputs, it is giving rise to same output, then that function will never have an inverse. Okay, so this is the rule. Every function doesn't have an inverse. There are some functions which do not have an inverse, and g of x is such a function. Okay. So this was it for the class, and we have completed the chapter function. And in next class, we will solve some questions and move to the next chapter. Okay.